My name is Steve Jensen. I'm a Principal Security Consultant with Veracode. And unlike a lot of the presentations that have been occurring at the conference yesterday and today, I'm not going to talk about building applications. I'm not a developer. I'm a penetration tester. I'm going to talk about breaking applications. Now, mobile development has grown and grown since 2007 with the iOS or the iPhone coming on the scene in 2007. Mobile development's just taken off with Android and everything else. And one of the things that we don't look at often are the tools that we use to develop these applications and the potential vulnerabilities that they introduce. So this is my credibility slide. Like I said, I'm a former software developer. I did software development for a company that developed banking applications. I did that for about 6 years. I've been breaking iOS apps and mobile apps in general since about 2009. And I've done responsible vulnerability disclosures for iOS applications for a myriad of industries, including the airlines, banks, credit monitoring agencies, things like that. Now, when I first started this presentation, or first thought of this presentation, my thought was it was going to be about penetration testers, people who were going to actually be breaking iOS apps like I do. And then I thought that was a little too narrow. And then I thought, well, software developers, iOS mobile developers would take advantage of this as well, because what better way to understand how to create secure software than to understand how attackers attack it? And then I thought, well, maybe that may be too narrow as well. So this presentation is really for anybody who has an iOS device and is curious to see how applications function, what data they store on the device, and in some cases what you can do to reverse engineer them and get to the actual functionality to see how they work. So today's agenda is basically going to be an overview of iOS analysis, a couple of the tools that are used in the industry to do iOS analysis. We'll talk a little bit about some tools that are used for reverse engineering. And then we're going to talk briefly about mobile development frameworks and how those have come onto the scene and have really made mobile development really a booming industry. So there are a handful of tools for iOS development, for iOS analysis that are used within the industry. The first one here is OTool. We can use OTool to analyze the iOS binary. It will help us identify header information. It will help us identify encryption information, stack smashing, automatic resource counting. All of these security features that Apple has implemented, we'll be able to identify if those are actually in place and implemented. Keychain Dumper is a tool that was created by a guy named Patrick Toomey. Basically, it allows us to dump the contents of the iOS keychain on a jailbroken device. Now, the tool that I've created, this IRAT, the iOS Reverse Engineering Toolkit, is basically a GUI interface to interact with all of these industry tools. It, in and of itself, is just a bag. You have to put all of these tools in it to use it. Now, all of these tools I'm talking about, OTool and Keychain Dumper, SQLite, they're all command prompt tools. What the IRAT tool does is it automates them for you, so you don't have to type 20 or 30 commands to get the information you want. The last one here is SQLite, which attackers will use SQLite the same way that developers will. Developers use it to create databases and store information. Attackers will use it to read those databases to see what kind of information's in there. And like I said, all of these tools are great, but they're command prompt based, which means you have to manually type all these commands. But the IRAT, the iOS Reverse Engineering Toolkit that I created, actually automates these processes for you. And what I'm going to do now is I'm going to jump out of the presentation. I'm actually going to show you it in action. Now, the iOS Reverse Engineering Toolkit itself is just a Debian package. It consists of 3 components. It consists of an iOS application written in Objective-C that you see on the device. It consists of a Python script that acts as a web server to listen for incoming connections. And it also consists of a handful of bash shell scripts that actually utilize and show the GUI. What you're seeing here is actually a shell script. Now, there are various dependencies that are required on the device, such as Python has to be installed in order to get the iRET tool to work. However, all you really need is a jailbroken device and Wi-Fi. And you can do all of the reverse engineering and analysis that you want. Now, the tools that are incorporated within the functionality of the tool itself are listed on the left. And when you fire up the application on your device by just launching the icon like you would any other iOS application, on the left-hand side, it will tell you whether or not these tools that are used in the functionality are installed. If they're installed, it'll show green and it'll say installed. If it's not installed, it'll show red and say not installed. At which point you can stop and go out to Cydia and download that tool or that that application you need to use to run the functionality, and then come back in and launch it, and it'll check to see if that tool's installed, and then it'll show up green. In the right-hand side of the frame, these are all the iOS applications installed on the device. Now, when you download an application from the App Store, it gets stored into the var mobile applications on the device. These are all of the applications currently installed on my test device. And we're going to select one. This one is called Smart Auction. It's by Ally, who used to be GMAC. This is an application. I don't really know much about it other than research I've done on it. I don't have any valid credentials. I've never even been able to log into the application because I don't have valid credentials. But I've installed it on the device to serve two purposes. One, to perform an analysis, and the second part, which we'll get into, is to actually reverse engineer. Now, what I'm going to demonstrate with this application is, as software developers, and I'll talk about myself as being one, we build applications. We build applications for people to use. But the code that we write is protected. It's intellectual property for the company or for the developer themselves. That should never be made public unless you're going to open source it, correct? So what we have here is binary analysis. This is the O tool executed automatically and the results dumped for us. We can see up here at the top with the header information, we see that this particular application supports the ARM version 7 architecture. It has PI, which is position independent executable, which is a security feature by Apple. It has that enabled. The encryption info down here, we see that the encrypt ID is 0. This tells us that the iOS binary itself is not encrypted. It has stack smashing implemented, which is basically they put a canary on the stack to prevent buffer overflow attacks. And then automatic resource counting, it does not have that enabled. It does not have this security feature enabled. Automatic resource counting is a memory management. It's kind of like a allocate and deallocate. The next tab here allows us to, it automates the keychain tool. It will dump the contents of the keychain for us. Within the keychain, Apple and developers store all kinds of information. They may store information such as usernames, passwords, URLs. It just depends on what they want to store. And the tool that was automatically executed dumped 6 different areas of the keychain. It dumps the keys, the entitlements, the generic passwords, the internet passwords, the identities, and the certificates. The two that an attacker would be most concerned about are the passwords. The generic passwords will contain information about your Apple accounts, Game Center, iTunes. It will have your username and password in here. It will also store information about every Wi-Fi access point you've connected to within probably the past 30 days. So if we scroll down through here a little bit, we can see generic passwords for Apple, Game Center, there's the account. If I scroll down here a little bit more, you'll start seeing the Wi-Fi connectivity, or the Wi-Fi hotspots that I've connected to, and be able to actually, this is my home Wi-Fi. FBI surveillance van is the name, and there's the password for it. So if we steal somebody's device, we can gain access to all of this information. Internet passwords, like I said, that can store URLs, usernames, passwords, any kind of information that would be beneficial to an attacker, to start hijacking somebody's account, to start stealing information. The database analysis tab, what this does is behind the scenes it automates SQLite, and what it will do is it will look for every database found within the application directory for this particular application, and it will load that database into a dropdown. Once we select one of these databases, it's going to automate the execution of SQLite to grab all the tables and dump all the information stored within those tables. And there's all kinds of information that developers will store within database tables. In this case, we have username, password, credit card number, expiration date, things like that. Software developers are notorious for doing debugging because we want to see how stuff works. We want to troubleshoot any potential issues. So we want to turn on debugging, and we want to execute the NS log so we can identify, what may have thrown an error. The log viewer here allows us to see the last 100 lines of the system log. And we can scroll down through this, and we can see that the keychain dumper here has been executed multiple times, and it's logged that information on the device. The second part here it will, just like the database, it will actually identify any log files or text files that were associated with the selected application. And we can select those log files, and we can actually read the content. In this case, theoretically, they logged a credit card transaction. Transaction was started, the username, the password used, how many items were in the cart, the credit card number, the expiration date, the CVV, everything we need to do to go out and start making purchases on our own. The plist viewer, the plist is property list, and it's basically the iOS configuration files. And the key configuration file within an iOS application is called the info.plist. And it will tell an attacker various pieces of information that will help them start attacking and reverse engineering these applications. The first one here is the app base key. And this tells us that the application was created in a third-party framework called Kony. Are there any iOS developers in here? So you're familiar with third-party frameworks like Kony and Titanium and things like that? So this tells us within the info config file, plist file, that the application is created using Kony. If we scroll down to the bottom of the info plist file, we can also see that the supported environment for that is JavaScript. So it was created in Kony, and the source code was written in JavaScript. Kony allows you to write source code in JavaScript and Lua. So now we have two pieces of information an attacker can use: how the app was created and what language it was created in. I'm going to skip the next two tabs and go to this one. This one will show you when you launch an application and then you close it, it takes a screenshot of the last image that was displayed for that application. And they use that screenshot as an animation or transition back into the app when you relaunch it. This is done automatically. However, developers can override it and show whatever screenshot they want to have. But as an attacker when an attacker takes a look at this, if the developer hasn't implemented functionality to overwrite and show a generic screenshot, we could actually have sensitive information displayed here. We could actually have account information, username, login, whatever, that they may have been, the page they may have been on when they closed the app, now it's exposed here. So now this is where it matters for developers. The analysis, okay, that kind of helps attackers determine, what we want to look at and what we want to go after. The reverse engineering tools are really where we get into the meat of the actual attack. And there's a couple of tools out there that we can use. We can use dump decrypted. On that encryption info, we saw that the crypt ID was 0. That meant the binary was not encrypted. However, if it was encrypted, we could actually use dump decrypted and decrypt it. And a lot of developers have said that I've talked to have been like, well, it's got to be a difficult process. It actually isn't. It used to be a difficult process when we had to do it manually, but dump decrypted was created by a German guy named Stefan Esser, and he automated that process. So all we have to do basically is launch the dump decrypted app and pass it the path to the iOS binary, and it does it all for us. And it decrypts. It creates a new file called the application name.decrypted, and all of the information is there. Once we've decrypted the application, we can use class dump Z. And basically what class dump Z allows us to do is dump all of the class information for the binary. So we can see all the classes, we can see all the methods, functions that are within those classes. We basically pseudo-reversed it kind of like a .NET reflector would allow us to reverse a .NET binary. We can actually see the class and methods and things like that. We can't see the source code, but we can kind of start getting an understanding by looking at these class and methods what they do. Attackers will start looking for things that do cryptography, encryption or decryption process, generation of keys, things like this. Now, class dump Z allows us to dump the class info in two ways. It'll allow us to dump all of the class info in a single file, or it will actually parse out all of the classes into single files and have all of their methods contained within those files. My preference is the second part, because I don't want to look through 3 gig file to try to find pieces of information I want. I'd rather search through class names and then start targeting class names that seem interesting. Now, Theos is my reverse engineering tool of choice. A lot of people in the industry use IDA or Hopper, any of these others that allow you to disassemble. I like Theos because it's permanent, it's more interactive, and I get a lot more information. And Theos basically, that's the verbatim from the actual Theos page, but basically Theos allows us to create iOS software without the use of Xcode. So we're not tied to a Mac, we're not tied to Xcode. It will allow us to create iOS software using this tool. Now, we can create applications, but for an attacker, we want to create tweaks. And what tweaks are they are basically fragments of an app that will target the behavior of another application. We can use tweaks to read the behavior of another application. We can use tweaks to modify the behavior of another application. And tweaks allow us basically to hook into a running iOS process. And once we are hooked into that process, we can target a class or classes that we want to hook into, and we can specify methods that we want to hook into. And using these methods, we can start writing our custom code, or writing custom code to run in conjunction with, or write custom code to actually overwrite what is currently being executed. Now, one of the things that Theos tweaks allow us to do is to log activity. Theos itself has a logify script that takes a class header file as a parameter, and then it spits out that header file in a format that Theos can understand. Because by itself, Theos wouldn't be able to work with it. It has to have certain formatting. Now, like I said, in 2007, when the iPhone came out, it created a revolution. And back then, if you wanted to create iOS applications, you had to know Objective-C. You had to have Xcode. You had to have a Mac. And so it kind of turned off a lot of corporations because a lot of corporations are Windows. A lot of corporations don't have Objective-C developers. It's kind of a niche language that you learned. So what they found was, I don't want to go out and hire a bunch of Objective-C developers, and I don't want to go out and buy a bunch of Macs, and I don't want to go out and spend all of this money just to create iOS applications. So corporations were not quick to jump on the iOS development bandwagon. So they either had to go out and spend all that money, or they had to go out and spend money to hire a group or a development firm or a freelancer to build these applications for them. However, in about 2009, 2010, these third-party mobile development frameworks started coming out. These frameworks like Titanium and Kony, they allow you to create mobile applications in a variety of languages. Now you're no longer tied to Objective-C. You're no longer tied to a Mac or tied to Xcode. Now corporations can go out, and if they have .NET developers, they can go out and purchase a multitude of third-party frameworks that support .NET languages. Or if they know JavaScript, they can go out and purchase one of these other third-party development languages. So when these third-party frameworks came out, it created a robust time frame of flexibility. They could still utilize the same developers they had in-house. Now they can use them to create iOS apps. And it vastly improved productivity. And one of the benefits of these third-party mobile development frameworks is that you can write the code once, and then you can compile it for multiple platforms. So I can write the application in JavaScript, and then I can set the compilation options to target iOS, build me an iOS binary, build me an Android binary, build me a Windows 8 binary, and build me a BlackBerry binary. So I write the code once, it spits out all these different binaries, and then I can submit them to the App Store, and there, we're done. So great productivity. You write it once, you're targeting all the applications. So corporations love these third-party mobile development frameworks. But they come at a cost. And the framework that I'm going to pick on today is Kony, which we saw in that plist file. That's why I selected that app. It's written in Kony, and it's a third-party mobile framework, and it's written using JavaScript. And we can start targeting it or identifying it because of the info plist file having those two keys. And then within the hierarchy of the directory, the application directory, there is a JScripts directory, and within that there is a app_scripts.js file. Now this file, if we took a look at it, is actually encrypted. And why do developers encrypt stuff? Because they don't want anybody seeing what's inside. So that right there is is a marker to an attacker that this is protected information, and we want to find out what's in it. Now, if we start dumping the classes or the header files for this application, we'll jump across. We'll kind of be able to correlate. Well, we're working with JavaScript. We're looking at JS app, and there's one class in here called JS script loader. Seems feasible that it would work with that JavaScript file. And within that JavaScript file, there is an evaluate script method. And this method takes two parameters. It takes a script parameter, and it takes a file name parameter. Now, being an attacker, I may start looking at this going, okay, maybe there's some kind of code or some source code or something in this file. I'm curious what I can do with this. So, if I jump out of here, and I launch my SFTP, and I come into the IP address of my device, which is 192.168.21.57. Once I gain access into this application, I'm going to show you real quick what we have here. Here's the Smart Auction application. Within the .app directory, which is really where the brains are, you can see down here there is a JScripts directory, and within that there is an app_scripts that we just saw. And if we do a quick look at this, we see it's gibberish. It's just encrypted information. It doesn't matter if you open it in a hex editor or text editor or any kind of editor, it's still going to be encrypted. So, like I said, this is something an attacker would look at and start honing in on, start targeting. So that's exactly what we're going to do. So the first thing we want to do is we want to go into Theos, and we want to create a tweak. So all we have to do, we have to provide 4 pieces of information. We're going to project name, which every project has to have a name. The package name, which is just a generic name that I've added. My name. And then down here below, there's a bundle ID. That is identified within the info.plist file. The CF bundle ID helps Theos understand exactly what process we want to hook into. This is the name of the process we want to hook into when it's running. We hit submit, and behind the scenes, it's building this tweak for us, compiling and doing all of that. And there's our confirmation at the top, and it returns us 2 files. The first is a make file, which I'm sure many of you know what that is. The second one is a tweak.xm file. Now, within the make file, we need to do 2 things, and only 2 things. First, we need to remember what the architecture was this application's targeting. And when we saw in the binary analysis tab, the application supported ARM version 7. So we're going to add an export args ARM version 7. The second piece of information we need to add is to identify the type of device we're targeting, the compiler we're targeting, and the SDK that we're targeting, so that it can compile it for this particular application on this particular device. So instead of trying to type all of that, I'm just going to copy this in. Those are the only 2 pieces of information we have to add to this file. The architecture, and then the target. And we save that. And then if we take a look at the tweak.xm file, we'll see that it kind of tells us some details about how Theos, the format that Theos expects. We can see up here at the top, it's got a %hook, and then it's the class name that we want to hook into. And then down here below, there's a %ORIG, which is original. That tells the tweak that if that missing the word now, but if that value is there, it's going to run the original code as well as our code that we implement or inject in there. The %log tells it to log the information, log all the parameters being passed to this method or this function. And if we connect the device and we're looking in the console, that stuff will be dumped out to the console. So and then at the end we have the %end, and it basically says, okay, now we're done hooking into that class. So what we're going to do real quick is we're going to come over to the header files, and we're going to, behind the scenes, it's automating, it's checking to see if the binaries encrypted. If it is, it automatically decrypts it. If it's not encrypted, then we don't have to worry about that. We can go on to the next step. The next step is to actually dump the class headers using class dump Z. And all the class headers get loaded into a drop-down menu just like it does on the database file and the database tab and a log viewer tab. And the header file that we were wanting to take a look at is the JS script loader. So if we do that and select that header file, behind the scenes it's automatically running through that Logify script to return that class header into a format that Theos can understand. And when it returns here, you'll see that it matches the format that was identified on the log tab, or in the Theos tab. So we have our %hook. The class is JS script loader. These are all of the methods that are being utilized. And then here's our end. And within each method, we see that there's a log command to log the parameters being passed. And then the %ORIG command, which is basically, execute the code that was originally there. Now, if we look down through some of these headers, we can see, or some of these methods, we can see contents of JS scripts directory. So it's going to check that JS scripts directory. It's going to see if that JS file exists. We can see the evaluate script, which has the 2 parameters we mentioned. There's a load JS scripts, which probably loads that encrypted file and probably decrypts it at some point. Run startup scripts, run scripts. So there's a variety of methods here that are associated with that script. The only one that really concerns us, all we have to do here real quick is just copy it, come back over to our Theos tab, go to our tweak.xm, copy it in. It's that easy to create a Theos tweak to start reversing iOS apps. But like I said, the only one that we're interested in is the evaluate script. That's the only method we want to look at because it's doing something with that file. It's taking parameters from that file, we think, and it's doing something with it. Now, if we save this and build it, respring the device, and launch the application, we would see a bunch of JavaScript being dumped to the console. That doesn't really help us, though. We don't really understand the context of what that JavaScript is. So what I've done is I wrote about 10 or 15 lines of code. And for those of you who don't speak Objective-C, basically what this code does is it will create a directory within the application's home documents directory. The name of that directory is JS files. The second part down below, it will take those parameters that are passed, that file name and that script, and it will create a file on disk, because obviously all of this is happening in memory. It will take that file name that is being passed and create that file on disk, and then write the content of that script parameter into that file. And every time this method is called, for however many files there are, it will do that for us. So we save these changes, and we build this. And basically what it's doing behind the scenes is it's automating the compilation process for us, and then it's going to return us a message that says, hey, it was successfully built, and it's installed in the library mobile substrate dynamic libraries directory. And we can confirm this if we go to our library, mobile substrate, dynamic libraries. Remember, it was called JS dump. And there's our file that we just created. There's our tweak. Now this tweak is going to hook into that process when it runs. Now if we go back into our application, here is our documents directory. We see there is nothing there. I'm going to stop the tool. I'm going to respring the device. Basically what respringing does is it restarts the software on the device. It's just a warm reboot. It doesn't restart the entire device, it just restarts the software so it can identify the tweak that we added, and it can use it. It's resprung. I wish you guys could see this, but here's the application. I'm launching the Smart Auction application that we're targeting. And when the login page loads, our tweak is complete. It's already run all of our code. It's done. Now we see if it works, and now we're going to get to see what the results of that encrypted file are. So here's the directory we created. Now, for every one that was called, here are all the JS files that were created. And there's 111 of them, I believe. 111 different JavaScript files. Now, if we were to look inside these JavaScript files, if we did a quick peek, we would discover something quite interesting. This is the actual source code of the application. All of it. It's 111 different JavaScript files the developer created for this application, and we have it all. This is what attackers want. This is the danger and the innate weakness associated with these third-party mobile development frameworks. You create applications, software, that's great. But do you ship your source code with your applications? No, nobody would ever do that. That's intellectual property. That's coveted. That's ours. That's something that shouldn't be disclosed. However, we just dump the entire source code of the application. And try to let this sink in. There are literally tens of thousands of iOS mobile apps in the App Store right now that are created using third-party mobile development frameworks. I've done research on 5 of them, and the 5 I've done research on, I can dump source code from. Now, think about it. Okay, yeah, we don't want to disclose our source code, but what's the real harm in doing so? Well, if your source code is secure, that's fine. But an attacker, with having the source code, I can start searching for additional vulnerabilities. I can start searching for ways to start attacking your servers, maybe find the servers you're communicating with. I can start attacking the additional resources. If your application it requires you to pay for it, or it has premium content that you need to upgrade to pay for, your source code, I can probably look through there and figure out how you're doing that. I can bypass it. And now I can get all your premium content for free. Or I can modify the source code and make it behave in a different manner. Maybe you have a game, and the game requires you to purchase certain products or purchase lives or something. Maybe I modify your game, and now all the lives are free. Or maybe I modify your application to give all the free content or all the pay content for free. I compile it, sign it, put it up on the internet. Now all my buddies have your software that you're supposed to be making money on, but they have it for free now. And the last one is the most important. Everybody is in a rush to market to get the newest and greatest widget out there because it's a moneymaker. Now, attackers are organized and they're well funded. If you've got the latest and greatest Flappy Birds out on the market and it's making $50,000 a week, I want a piece of the action. I can dump your source code, clone your app, and now I become a competitor. So all of these things here are issues associated with third-party mobile development frameworks. As software developers, we want to use tools that help us do our job easier, more proficiently, or more efficiently, and more productive. But sometimes we overlook some of the weaknesses that are associated with them. I've done it, I'm guilty of it, and everybody in the industry is. And it's not our own individual decisions, it's something that needs to be vetted by corporations. Your company needs to vet these products before using them. And a lot of companies don't because they look at the benefits of productivity and flexibility, but they've never really had the opportunity to go through and vet to identify if there are any weaknesses. As far as I know, there's only a handful of people that have actually done any type of third-party mobile development framework research. And I know about 3 of them. And this is a huge area where that is not being addressed. You all work for corporations, and I'm sure all your corporations create iOS apps to target your customers. And if you're using third-party mobile development frameworks, this poses a problem for you. So, summary, IRAT, yeah, it's a great tool. It helps attackers and people like me, penetration testers, do analysis and reverse engineering more effectively and more efficiently. It automates the tools, and it helps do complex reverse engineering. It lessens the learning scale in doing that. The mobile development frameworks, like I said, they're great for productivity and flexibility, but if you're dumping your source code, it's probably not a good idea. And the application that I tested, I don't have any credentials for. I downloaded it off the internet, or off the App Store. I'm not a valid user of it. All I did was install it and launch it, and that's what we got, source code. And it affects numerous frameworks, like I said. I've looked at 4 or 5, and every single one of them I can dump source code. And because we have a multitude of these third-party frameworks out there, we have a multitude of applications being created, and last count, there were like 1.2 million apps in the iOS App Store. And with all of these third-party mobile development frameworks, I wonder how many of those are actually possible to dump source code from. It'd be a little bit of a shock to corporations to find out that, you could take the app, download it, not have any valid accounts, and just dump the source code for it. The IRAT tool itself is free, GPL, it's out on GitHub. If you're interested in using it if you're an iOS developer and you want to see if there's any type of weaknesses or anything in your apps, you can use it. Analyze the content, make sure you're using the proper security features that are implemented by Apple. If you have any questions over it, you can contact me on Twitter. Other than that, that's my presentation. It was just kind of a forewarning as to the dangers of these things. So I'll open it up for questions if anybody has any questions. Yeah.
Sure. IRET tool useful if the iOS application is not written using third-party frameworks?
We can still do things, we just can't dump source code. We can take it all the way up to the point where we can dump headers and log and see information. We can still dump the content or the parameters being passed to the functions to dump encryption keys and things like that. We just couldn't dump source code. So yeah, I would recommend to develop in native Objective-C using Xcode.
So is the source code disclosure really only a concern for like the HTML5 based frameworks? I know like Xamarin, I believe they actually compile to a binary. So I don't know if it works the same way.
I've looked at Xamarin. I haven't done full research on it, but yeah, I'm not sure if a lot of the ones I've looked at have been like PhoneGap, where they have the HTML stuff, Coney.js stuff, some of the other things like that. I haven't gotten into a bunch of them like Xamarin that does .NET assemblies, though. Any other questions? Yeah.
So do you know of any ways to protect against like the Theos logging parameters and all that? Like, is there any way to protect against that? Or is that something we have to live with?
Yeah, there's no way to protect it. And that's one of the things that corporations need to understand is when you you basically distribute your application out, it's out of your hands now. It's on the device. You have no control over it. And using Cydia and Mobile Substrate and Theos, we can do whatever we want with it. We can make it behave in any way we want. Hopefully, if the software is developed correctly, the vulnerabilities will only target one user, and that is the user of the device. However, I have seen instances where the same encryption key was used for every installation. So if I can dump it from my device, I can hijack everybody's device and decrypt all of their information. Any other questions? All right, appreciate it. Thank you.